Hello, my name is Paul Gilbert, and I'm the CEO of Quanser. And we're back at Quanser Café, where we're talking about AI and complex modern engineering. I've been inviting a number of global leaders in education to help me unpack some of the issues surrounding how we can modify engineering programs and engineering education to try and get ready to support more complicated systems that exist in the world. You can find out more about the guests in each episode, as well as some of the projects highlighted in our conversations by visiting the links in the podcast description. If you're listening or want to watch the full podcast with subtitles, visit the Quanser Café on quanser.com. Today we're exploring the topic of developing professional skills, skills that go beyond traditional technical expertise and are becoming increasingly vital in modern engineering. From lifelong learning to ethics, we'll be discussing how education is changing to prepare the next generation of engineers to tackle complex global challenges. Joining us for the final time in this season are Dr. Balázs Nagy and Dr. Ken Ball, who will share their perspectives on how universities can integrate these essential skills into their programs, and how industry and education can work together to create well-rounded, future-ready engineers. So how is engineering education changing? I caught up with Balázs to explore this further.
So we were used to that frontal type of education, and a professor in front telling the important things that you need to know, but you don't have too much interaction. Sometimes you have the question session at the end of the lecture. Nowadays it's totally different. So nowadays we are, as you mentioned, project-based learning, but we can call challenge-based learning, the flipped classroom technique, and many other news that actually CEFI presents every year to our audience, made by the experts of engineering education research. So we have many new tools involving the students right from the beginning. So project-based learning, it operates in a way that the students right from the beginning does a certain project. And a project always implicates a lot of different topics, which is not only hardcore engineering. So that's where the sustainability issue comes into mindset. So we really need to make products, even if it's a student product, that are designed to last long and designed to have less impact on the environment and the ambient. The same for ethics. We have to teach the students to have a mindset, to think about the long-term effect and impact of their designs. Otherwise, the society will not benefit from it. Maybe benefits from a very short term only, but for the long term, not. So this kind of thinking is already implemented in engineering programs. So we have a certain percentage dedicated in courses to ethics, to sustainability, also to the economic, the financial management of projects, leadership eventually. So we are trying to give the transversal skills to students right from the beginning, so that they don't think it's just a kind of unnecessary addition onto the hardcore technology and technical skills, but it's something already embedded when you design a new product, for example.
So I know, obviously, clearly, because we've talked, I know you're passionate about this, and there's a lot of work being done at Budapest, your university.
Yeah.
Across the European spectrum, there's hundreds, if not thousands, of universities. Do you think the same thing is happening across the board, or is this a kind of a big problem that leaders like CEFI and the other alliance you were talking about have to pull people in and encourage them and train them?
What I see, fortunately, is that the new generations coming into universities and the new generation of corporate leaders, they have a certain demand towards such education. Some decades ago, I remember when I was starting as a professor, corporates were approaching universities to give them the so-called soft skills at the time, because students just really didn't get them at the university education. Nowadays is getting much more wider than that. So what you see that we even changed this word soft skills to more transversal skills, because it created a sort of separation from engineering core disciplines. It's not, it's the same thing. It has to be integrated and it's together. So what I see on the landscape, especially in Europe, where I have a bit more insight, that it's really getting into all engineering programs, fortunately, to have this really a global perspective that students will need and use in their real working life, let's say that way.
Yeah, it's interesting because in the meetings that I've been to and talking to a lot of people, I think you're right. I think if I go back 10 or 15 years, there was a bit more resistance. But now, as you said, there's a new generation of students and there's a new generation of corporate leaders that want to bring these transferable or professional skills into the mix. But there's also this challenge that you have so much that students need to learn in terms of engineering, like the pure
Oh, yeah.
engineering piece is a lot, and then you add in all of these other layers on top. And if I could also say, there's a shifting landscape that you get different requirements coming from your government bodies as to what you should or shouldn't do. How do you kind of balance that mix and make it so that you give them what they need, but you don't overload the faculty and don't overload the students?
Yeah, inclusively, we are trying to reduce the contact number of student hours that they have to face professors, so they can have more self-sustained learning and self-reflective learning and things like that. So it's really a challenge. But at the same time, the new methodologies, once again, project learning, it already integrates this kind of system thinking. So it comes with the questions. And once you go to a company, and we try to connect students with companies right from the beginning and societal challenges, once they go there, they see that these questions are there. It's not only that I have to solve an equation on a beam, for example, to having a certain load, but it comes to that question that I have that beam, it will be put out to some bridge, and it has to stay the different weather conditions. People will go through that bridge. We don't want that bridge to collapse. So there are all kinds of questions that people want to understand. And once you change the methodology, and you don't start from A plus B equals C, but you start from society wants us to build a bridge. It changes the mindset, and it operates in a way that people pick this up faster instead of having it as a separate discipline, for example.
That's interesting. So you've been doing this for a number of years. Do you find the students are very receptive to this approach? Do they find it more motivational?
No, they want it.
They want it.
It's not like they are receptive. They want it more than
Oh.
we can do it. So we have to catch up with them at the end of the day and show them how it works. We have actually engineering universities, most of them are in a very lucky situation because we live in our own projects towards the industry. We don't only do basic research, actually, it's less basic research, it's more applied research that we are doing. So it's very easy for us to bring in real life experiences and show it to the classes. And that's what students love. And we have the opportunity in many cases to involve students in some of these projects. So this is something that attracts a lot of interest and a lot of newcomers.
It was a real pleasure to have Balázs with us this season. Now let's hear from Ken Ball on how George Mason University are preparing students with the skills they need for the future.
So we want to be sure that we are, after all, a university, and our number one mission is to prepare students to have great careers and to contribute to society. So we never lose sight of that. And we try to be sure that they're as close as we can get them to being career ready when they leave here. And also to inculcate in them this belief in lifelong learning, right? And
Right.
that you're never finished learning, and you always want to be able to continue to adapt. And so we do the same thing, in all of our programs. We're constantly checking in with our employers and our constituents to be sure that from their viewpoint, we're meeting their needs, and whatever improvements we can make to our curriculum, whether it's adding new courses or adding new programs or improving what we're already doing. We want to be sure too that the experience they get in the more formal part of the curriculum, the classroom teaching and instruction, that we are in fact achieving the outcomes that we hope to achieve in a way that helps our students to be successful.
Well, it's fantastic. I run an engineering company, so one of the things I absolutely look for, or we look for, in hired into the engineering team, is the ability to speak in sentences and have a good conversation and ask questions and be able to challenge each other respectfully, be able to present those kind of, their ideas and withstand the criticism or challenges that they're faced with. I would argue probably more than 50% of the time is spent, debating or
arguing, if you like, about what's the right approach for a particular project. But when you reflect back on the last 10 years, you've had the industry advisory board give you those ideas. Are you now seeing preference for your students over other places in the region? Do your students get snapped up?
They get snapped up. We are the largest university in the region, and the workforce demands are very large, and so, but again, we've been responsive to that, and especially in engineering computing fields, we are providing graduates that companies are looking for, especially in again in the Northern Virginia region. You've got all kinds of companies that we've got data centers, the Amazons, and and even when you get into like for example, data centers, Northern Virginia is the world's largest concentration of data centers. That creates a lot of power demands. So we're also working with the biggest utility in this area, Dominion Power, to come up with a new power engineering program. And so, and that supports the data centers and the students who are working there and understand all the aspects of that. You get into sustainability and using renewable energy, but then you get into resilience of the infrastructure, with the grid and the smart grid and updating that. Everything today, GPS plays a big role in everything. You've got to maintain precise time, to 5G standards for all kinds of transactions and communications. A lot of our research that we do is for resilient positioning, navigation, and time to keep digital systems going. And so it really creates a very intertwined network of faculty, research, students, working with partners, so that everything continues to work together. And but again, that takes back to things really being multidisciplinary, and it's the digital world and everything's connected digitally. You've got to really be sure that you understand all aspects of that. And so that's really what we try to stay current in, so that we can support all of that. Being a large university and being a large, the university is about 40,000 students, and the College of Engineering and Computing being close to 12,000 students, we're really producing a lot of the workforce. One thing that's kind of unique for us, unlike a lot of universities, about something like a very high percentage, maybe 85% of our students when they graduate will stay in the region and work. That's not terribly surprising when you think about where we are in the national capital, and all the big companies are here, and a lot of startups as well. But our students will stay here and contribute, and then we can pull them back in once they're working. So that next cycle of people from industry helping us with our students and our programs, and so they give back, and that helps us to stay current.
That's fantastic. Yeah, that's fantastic. And talking about graduate students now, because things are changing so fast, are you seeing a growing demand for your support in skills development? Postgraduate. You mentioned lifelong learning. Other companies coming back and saying, "Hey, we've got a lot of engineers in their mid-30s, but they can't come to campus. They've got young families. They have other responsibilities. Are you offering those kind of programs?"
Yeah, so we have well, again, we can do a lot of things because of where we are. We do a lot of programs that cater to students working part-time, for example, especially at the graduate level. So full-time working professionals can stay engaged and continue to earn degrees, whether it's offering evening classes or classes that are online. Or they can come to the if they're working in the area, living in the area, they can come to campus. So we're also trying to make it easy for people to continue to engage with us no matter where they are in their careers. And so I think that that's very important. And we're trying to convene groups. We work with our trade organizations. There's a group called Northern Virginia Technology Council. So we're very That's a very large trade organization working with companies. There's a group called the Greater Washington Partnership. So there's all kinds of opportunities for us to interact with folks in industry and government and to make sure we understand what their needs are. We're also very responsive. You know, if people come to us and say, oh, we'd love for you to offer coursework in this area, or even different credentials, right? We talk about alternative credentials,
Right.
certificates, badges, you know, whatever it is, we're willing to, again, our mission as a public research university is let us understand what the needs are, and let's work together to meet those needs. I should also say too that we work very closely with we're fortunate to have a very strong, very large community college system, and we make
Okay.
it very easy for students who get a 2 years associate degree to transfer in seamlessly to complete a 4-year degree if that's something they're interested in. And so that again helps us to meet the workforce needs. And we even work with, you know, at the P through 12 level with our school system to do things like dual enrollment and college credit in the high schools and things like that. We do a lot of outreach. We just had you know, numerous summer camps for, you know, middle school, high school students, even elementary students. We want them to get interested in different fields and consider pursuing a degree program in engineering and computing. So we do a lot of outreach too for the younger market to create that pipeline to meet needs, and also for the community, right? So we're engaged in many different ways with the community around us, so that they become aware of what the opportunities are and what the needs are, and what the problems are, so that we can all work together to solve them.
Ken Bull there sharing his insights. Thank you so much, Ken, for being part of our conversations. Well, that brings us to the end of today's episode. We've had a fascinating discussion on how the landscape of engineering education is shifting to prioritize not just the technical skills, but also the vital professional competencies like lifelong learning and ethics. It's clear that as the world becomes more complex, these skills will be critical for engineers to thrive and lead in solving the global challenges ahead. Thank you so much for tuning in, and a huge thank you to all of my guests for taking the time to chat. We hope everyone has enjoyed Quanser Café Season 2. We're keen to hear your thoughts about the season or potential topics or guests to feature in future episodes. Please leave comments or connect with me on LinkedIn. And to learn more about Quanser, visit quanser.com. Until next time, this is Paul Gilbert signing off from Quanser Café. Goodbye.